Hi there. Hope you have a fantastic day today. This lesson, I will go through 2022 exams paper. Of course, there is a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. First one. So we need to show that f double dash x is equal to this. And we already given f dash x. So this means that we just need to differentiate one more time. So let me just write this down. So f double dash x is equal to, which is differentiate this. And don't forget, if we have y is equal to e f of x. So to differentiate the functions, we differentiate this function first. So f dash x. So that give me y dash is equal to f dash x e to the f of x. So don't forget. So what we do, we first of all, we differentiate negative 2x. So give me negative 2. So now it becomes negative 2. We times the function, so minus 2x. And then we differentiate this function here. So we use product rules. So let me just write minus. So differentiate, first of all, we differentiate 2x. So if we differentiate 2x, it give me 2. So that is 2. And then we time by the second function, so minus 2x. And then we differentiate the second functions. This function here, of course, we differentiate the second functions. So we differentiate the power function here, f of x if you like. So differentiate negative 2x, give me minus 2. So we time by negative 2 e to the negative 2x. So what I did was I just differentiate this. And don't forget, we need to times by the first function. So the first function is 2x. So we time by 2x. So there you go. Now what I do, I just simplify this. So that will give me negative 2 e to the negative 2x. And then I minus bracket 2e to negative 2x. And a negative with the positive give you a negative. And we have 2 times 2x, give me 4x. So that becomes 4x e to the negative 2x. So now what I do, I just remove the brackets. So that will give me negative 2 e to the negative 2x minus 2 e to the negative 2x, and negative times negative give you a positive. So plus 4x e to the negative 2x. So what I do now is I just collect like terms. So these are like terms. So that will give me negative 4 e to the negative 2x. So I'm just going to write positive first. So that is becomes 4x e to the negative 2x and minus 4 e to the negative 2x. So now what I do, I take out the common factor. So the common factor is this one here, 4 and e to the negative 2x. So I take it out. So that would give me 4 e to the negative 2x and live with x minus 1. So there you go. So now I just write in this form, okay? So I just put the 4 in the front and then x minus 1 and then this e to the negative 2x, I just write it back. E to the negative 2x. So there you go. Part B, to find the stationary points, this means that f dash x is equal to 0, okay? So f dash x is equal to 0. So we know that f dash x is here. So let me just write this down. So f dash x is equal to e to the negative 2x minus 2x e to the negative 2x. So let me just, and we know that f dash x is equal to 0. So this means that e to the negative 2x minus 2x e to the negative 2x is 0. So I just take out the common factor. And the common factor in this case here is this one here. So that means e to negative 2x, I take it out. So that becomes 1. And I take out e to negative 2x. So the second term is left with this. Okay, so equal to 0. So this means that e to negative 2x is equal to 0, or 1 minus 2x is 0. So we know that e to the negative 2x is never equal to 0. This means that this is no solutions. And this one here, we can just move the negative 2x on this side, become 1 is equal to 2x. And I can also write 2x equal to 1. So 2x is equal to 1. And I divide by 2 on both sides. So x is 1 over 2. So now we need to find the y value because stationary point. So we need to have x coordinate and y coordinate. So now what I do, I just go f of a half. So that should give me, so we know that f of x is this. So keep that in mind. So x e to the negative 2x. So that will become x is a half e to the negative 2 and a half. So that will give me, so these two here cancel out, give me negative 1. So e to the negative 1. Okay. So that will give me a half of e to negative 1. But then I can bring this down, become 1 over 2 e to the power of 1. So that is exactly the same as this. Let me just write this down. So that will give me 1 over 2 e to the 1, which is 1 over 2e, if you like. So therefore, the stationary point is, so you got therefore, the stationary point is a half and 1 over 2e. So keep that in mind. But then we need to determine the nature. So either maximum, minimum, or point of inflections. So to do this, so I can just substitute a half into the second derivative functions. So let's test, okay? Let me just draw a line on here. So now, so f double dash a half. So that give me 4 a half minus 1 e to the negative 2 a half. So what I do, I just put this on a calculator. So I just go 4 brackets. So a half minus 1 is negative a half. And negative 2 times a half is negative 1. So e to the negative 1. Easier, that's all. So negative 0.74. So that means less than 0. So you go, therefore, maximum at a half 1 over 2e. So there you go. So part C. To sketch this graph, we need to find the point of inflection first and then x and y intercepts. Okay, so keep that in mind because we already have stationary point. So let's just find point of inflection first. So point of inflections is when y double dash is equal to 0. So y double dash is equal to 0. And we have y double dash is here. So this is y double dash. So let me just write this down first. So that is 4x minus 1 e to the negative 2x is equal to 0. So now what we do, we have 4x minus 1 is equal to 0 or e to the negative 2x is equal to 0. And we know that e to the negative 2x is never equal to 0. So no solution for this one here. No solution. And with this equation here, if I divide by 4 on both sides, so x minus 1 is equal to 0. So therefore, x is equal to 1. Okay? So x is equal to 1. So when x is equal to 1, we need to find the y values. So that means f of 1 is equal to, and we know the f of x is this function here. So become 1 times by e, and we have negative 2 times 1 is 2. So I bring it down, become 1 over e squared. So that is the point inflections could be 1 over e squared. Of course, we need to test it whether it is a point of inflection or not. To do this, we need to find the concavity for this, okay? So let me just write this down. This is x, this is f double dash x. And we have 1, left of 1 is 0.5, and then right hand side is 1.5. And we have 0 for the y double dash x or f double dash x if you like. So now I just put down on the calculator. So let me just write this down here first, okay? F double dash x is 4x minus 1 e to the negative 2x. So now just substitute this value in. 4 brackets 0.5 minus 1 brackets. So e to the negative 1, because 2 times a half is 1, okay? So there you go, negative 0.74. So negative 0.74. And when x is 1.5, so I just change the value from 0.5 to 1.5, okay? So quicker. So that means 2 times 1.5. And I need to change this one here to 1.5. So there you go, 0.099, so on. Just go 0.1 we do. There you go. So negative, 0, and positive. So now since, so therefore, it is a point of inflections. Okay, keep that in mind. So now we need to find the x and the y-intercept. So let me just do it on this side here. So this means that when y equals 0, that is x-intercept, okay? So that means x e to the negative 2x is equal to 0. So this means that x equals 0. Or e to the negative 2x is 0. So that is no solution for this. So therefore, the x-intercept is x is equal to 0. So therefore, let me just write this down. X-intercept is equal to 0. And to find y-intercept when x is equal to 0, so y is equal to 0 e to the 0. So the answer is 0. So this means that y-intercept is equal to 0. So we have x-intercept and y-intercept at 0, 0. Keep that in mind. So let me just get this first. So let me just quickly draw it on here, okay? Of course, you have to have ruler and everything. Let me just quickly do it. That's all. So to do this, so we have the turning point. Let me just write x and y-intercept first at 0, 0. And the turning point, so this is the stationary point. Maximum turning point, if you like. A half and 1 over 2e. So a half, 1 over 2e is roughly here. Doesn't matter, okay? Let me just write this down. 1 over 2e. It's just like 1 over 2 times e is just roughly like 6, okay? So 1 over 6, just roughly, okay? That's all it is. And then it's maximum. So your graph is go up and down. But then we only have one x-intercept, that is 0 at 0. So therefore, your graph should go approaching to the x-axis. And it never cut the x-axis again, okay? After the 0. Keep that in mind. Otherwise, you can just find the limit. Remember limit when x approach to infinity. So the functions is x e to the negative 2x is become like this. Okay, limit x to infinity. This one is just like x over e to the 2x. So a number divided by a very large number. So that means it's approaching to 0. Okay, so keep that in mind. And when x approaching to negative infinity, so that becomes like this. It's like limit x approaching to negative infinity, x e to the negative 2x, it become like this. Okay, negative infinity, you times by a positive, a large number, okay, because the negative times negative give you a positive. So it become a very large negative number, if you like. So you start from here, it go like this. So something like that, okay? So keep that in mind. So that's 0 here. So there you go. So this is x, this is y. And this is f of x. So there you go. Question 28. So to work out the area of this, so what we do, we need to find the area of the sector. That is this area here. And then we need to minus this triangle here, the area of this triangle. Okay, keep that in mind. But then we know that from here to here is 1 because the coordinate is 1, 1. And the y is 1 as well, this value here. So this is a right angle triangle. Of course, then we can find out the radius of the circle by using Pythagoras theorem. So 1 squared plus 1 squared is 2. So this radius here is root 2. And of course, because it's a triangle, in fact, it is an isosceles right angle triangle. So therefore, angle theta must be 45 degrees or pi over 4. Okay, 45 degrees pi over 4 because we have to deal with radian. Okay, so now to work out the area, so we need to find the area of the sector is a half r squared theta. That's a rule. And we need to minus the area of a triangle. Area of triangle is a half times base, which is 1, and the height is 1 as well. So that's it. And we know the radius is root 2. Let me just write this down. So that become a half times root 2 squared give me 2. And the theta, the angle, is pi over 4. So times pi over 4. And we minus a half. Because 1 times 1 is 1. And then a half times 1 is a half. So that will give me, that cancel out. So that give me pi over 4 minus a half. So there you go. Now we need to show that A is equal to B is equal to 2 from the hyperbolic function. So this function here. So we know that when x is 0, y is 0. So we have 1 point already. So we just substitute that in. So 0 is equal to A b minus 0 minus 1, which is substitute into this function here. So now b minus 0 is b. So that becomes, and I can move this negative 1 here on this side become positive. So that means 1 is equal to A and b minus 0 is b. And I times b on both sides. So that means b is equal to A. So keep that in mind. Okay, first step we're done. And then we do the second step is we know that at this point when x is 1, y is equal to 1. So let me just substitute that in. So this means that y is 1. So that becomes 1 is equal to A over b minus 1 and minus 1. So now I just plus 1 on both sides. So this means that this is cancelled out. And this one here, we plus 1 on this side. Or we can just move negative 1 on this side. Okay, so that means 1 plus 1 is 2, if you like. So 2 is equal to A, b minus 1. And what I do is I times b minus 1 on both sides. So that becomes like this. Okay, 2 b minus 1 is equal to A. So if I expand the brackets, so this means 2b minus 2 is equal to A. Is remember A is equal to B and B equal A. So I just write B first. And what I do, I move B on this side and 2 on the other side. So that means 2B minus B will give me B. Okay. And the negative 2 I move on that side becomes positive 2. So there you go. So now this means that A is equal to B is equal to 2. So there you go. Part C. So we need to find the shaded area. Okay, so that means this area here. Okay, so we need to find this area. So to work out this area, so we need to find the area underneath of this hyperbola. And this area here, we already found that is in part A. So pi over 4 minus a half. So don't forget. So we just need to work out this area here. And then we just add pi over 4 minus a half. So to work out this area, so that is, so area is equal to, we integrate from 0 to 1. Okay, this is 1 here. So 0 to 1 and A and B is 2. So that means 2 and 2 minus x and then minus 1. So that is the function. So don't forget. And then now is dx. And then we add the area of the segment. That is pi over 4 minus a half. So this area here, don't forget, okay? We add that on top. So now what I do, I just integrate the brackets here. So that will give me, so to integrate, so let me just write here. If I integrate 2 minus x dx, so I can take the 2 out. So it's like this, 1 over 2 minus x dx. But then if I differentiate inside here, it gives me -1. So remember, so if I integrate f dash x over f of x, so dx, of course, that will give me ln of f of x. So therefore, to make it 1 become -1, I just time by negative. Okay, so that become negative. So let me just clear this. So that becomes -2 ln of 2 minus x. Absolute value, -2 ln of 2 minus x, but we know that is positive anyway if we substitute the value in. So I can just put bracket. And we minus integrate -1, give me -x if you like. So then that becomes this, okay, from 0 to 1. And don't forget, we add pi over 4 minus a half. So now what I do, I just substitute the value in. So that will give me, so when x is 1, so we replace 1 in the x values. So that becomes -2 ln 2 minus 1, give me 1. So ln of 1. And then minus 1, that's for x equal 1. Then we minus, so when x is 0, so become -2 ln 2 minus 0 is 2. And then when x is 0, so -0. So that's it. That's done. Okay. Otherwise, you can just -0 like that. So you can write like that if you like. And don't forget, let me just clear this first. So we just need to plus pi over 4 minus a half. So then we need to simplify further. So this one, don't forget, ln1 is 0. And we have negative and -2 ln of 2. So that give me positive. So that is equal to 2 ln of 2. And let me just write this down. Plus pi over 4. And we have -1 minus a half. So 1 plus a half is 1.5 or 3 over 2. So that becomes -3 over 2 square units, if you like. So there you go. Question 29. So the sum of the area of the rectangles form a geometric series. So we need to show that the limiting sum is 2. So first of all, okay, the sum of the series is the area of the rectangle. So we know that the area of this first rectangle, this is 1 and this is 1 because of width of the strip. So 1 times 1 is 1. Okay, this area 1 is length times width. So 1 times 1 is 1. And this area here is, we need to find the height of the rectangle or the length. So this one here, when x is 1, so we substitute in here. So that means the length of this is 2, power of -1 is a half. So a half times 1 is a half. So this area here is a half. So remember that, okay? And the length of this rectangle here is when x is 2. So when x is 2, so the y value for this is 2 to the -2. So that is a quarter, if you like. So it's a quarter, the length of this, okay? So the area of this is a quarter times 1. So the area is a quarter. So let me just write this down. So the first area is equal to 1, and we add the second area is a half, and we add the third area is a quarter, and so on. So keeping adding. So we know that I is the first term is 1. And the common ratio is a half divided by 2 or a quarter divided by half. So give me 2. So common ratio is 2. And we know that the limiting sum, so the area of the rectangle is limiting sum. So that is s of infinity, limiting sum is I, 1 minus r. Keep that in mind. So now what I do, so this one here is equal to I is 1, 1 minus r is a half. So that means become 1. 1 minus a half is a half. So 1 divided by half. So it just times by, flip that 2 over 1. So it's equal to 2. So there you go. So the limiting sum of this series is 2. So part B. So we need to show that this is equal to 15 over 16 ln of 2. So this is the area, okay, of the function between 0 to 4, if you like. So first of all, we need to know that integrate I to the f of x. So that becomes 1 over f dash x. A to the f of x, and then we divide it by ln of a. Or we can times by 1 over, okay, so keep that in mind. So what I do now is I just evaluate the left-hand side, okay, so keep that in mind. So I integrate from 0 to 4 to negative x dx will give me, so I differentiate f of x, give me negative 1. So I divide by negative 1. So 1 divided by negative 1 is negative 1. Okay, keep that in mind. And I times by the functions, so which is 2 negative x. And then we times by ln of a is 2. So 1 over ln of 2. And that is from 0 to 4. So keep that in mind. So when x is 4, so that becomes negative 1 times 2 to the power of negative 4. So that becomes negative 2 to the negative 4. I just replace x with 4, that's all. And times by 1 over ln of 2. And then we minus, and we brackets when x is 0. So that becomes still negative 1 times, and 2 power of 0 is 1. So that times by just 1 over ln of 2. So there you go. So let me just sort this out. So this will give me, so this one here, we can bring it down, become positive. So that becomes 1 over 2 to the power 4. And 2 to the power 4 is 16. So this is the same as this, okay? So 16 ln of 2. We minus, so, and these two minus together become plus. So then we add 1 over ln of 2. So now I just need to simplify this, okay? To simplify this, so what I do, I just times this by 16 and this time by 16. So there you go. So now it's just, they are same common denominator. So minus 1 plus 16, it's the same as 16 minus 1. So that 16 minus 1 is 15. So that will give me 15 over 16 ln of 2. So there you go. Part C. So we need to use part A and B to show that e to the power 15 less than 2 to the power 32. So in another word, so we know that the area of the rectangle, which is sum of all the rectangle, is greater than the area of the functions under the curve here from 0 to 4. Okay, so keep that in mind. So that means the area of the rectangle is 2, and then the area from 0 to 4 is this. So in another word, let me just write this down. Okay, so 2 is greater than the area under the curve from 0 to 4. So that is the area under the curve from 0 to 4 is 15 over 16 ln of 2. So there you go. So what I do, I just multiply by 16 ln of 2. So that give me 32 ln of 2. That give me 15. So what I do, I use log law, so bring this up. So that will give me ln of 2 power 32, which is greater than 15. And if I unlock both sides, so that means 32 is e to the power of 15. So now, therefore, e to the 15 is less than 2 power 32. So there you go. Last one. First of all, we need to know that f of x, that is the cumulative distribution functions. So that is equal to integrate from I to x, f of x. And f of x is the probability density function. So keep that in mind. So we know that first of all, when x is less than 1, so the cumulative distribution is 0. And then when x is between 1 and e to the power 3, the cumulative distribution function is this. So in another word, it starts from 1 to e to the power 3. The cumulative distribution functions is from 1 to x, f of x dx. So keep that in mind, because when x is greater than e to the power 3, the cumulative distribution function is 1. So that means is the range is only from 1 to e to the power 3. So in another word, if we integrate the probability density functions from 1 to e to the power 3, it should give me 1. So f of e to the 3 is equal to integrate from 1 to e to the 3 f of x dx. So it should give me 1. Okay, so remember that. Okay, so that means f of 3 is equal to 1. So that means 1 is equal to 1 over k ln of e to the 3. Okay, keep that in mind because we need to know that f of e to the 3 is equal to 1. So this means that 1 is equal 1 over k times 3 because ln e to the 3 is 3. So then I just times k on both sides. So that means k is equal to 3. So therefore, k is 3. There you go. Last one. So we know that, first of all, p of x less than c, that means f of c. Okay, keep that in mind. And we know that k is 3. So that means f of c will give me 1 over k. That is 1 over 3. Because k is 3, ln of c. Okay. Now, another thing is this. And we know that p x greater than c. So that is the same as 1 minus p x less than c. Okay. Keep that in mind. And this is exactly the same as 1 minus 1/3 ln of c. Because it's from here. Okay. Keep that in mind. And we know that this is equal to 2 times that. So that means 1 over 3 ln of c. That is this part here. And then we need to sort out this. That is equal to 2 lots of this part is here. So that will give me 1 minus 1/3 ln of c. So what I do, I just times 3 on both sides. I just want to get rid of the fraction. That's all. So ln of c equal 3 times 2 is 6. 1 minus 1/3 ln of c. So then I just remove the brackets. So ln of c equals 6 times 1 is 6. And 6 times negative 1/3 give you minus 2. So minus 2 ln of c. So I move this negative 2 ln on this side becomes plus 2 ln c. So 1 plus 2 give me 3. So that means 3 ln c is 6. And I divided by 3 on both sides. So 6 divided by 3 is 2. So ln c is 2. So therefore, if I unlock both sides, so c is equal to e to the power of 2. So c is equal to e to the power of 2. So there you go. Thank you so much for watching. Bye.